Hello everyone. For this video we're going to look at a related rates problem. So we're going to look at some applications of the derivative. And so let's just get started. It says a circular pool of water is expanding at the rate of 16 pi inches squared per second. At what rate is the radius expanded when the radius is 4 inches? Okay, so first thing you want to do is be able to find what we know and what we don't know. And let's see, what do we know? We know that it's a circular pool. Alright, so I'm going to draw myself a picture here. And we know that it's expanding at a rate of 16 pi inches squared per second. So this is a rate. It's a rate of area. So because if you look at the units that's being used, inches squared per second, I know that is my rate in area. And then it's saying at what rate is the radius expanding when the radius is 4 inches. Alright, so there's a few things here that we are given. So the first thing that we're giving is, we're given the rates in regards to area, so dA dt. We are given as 16 pi inches squared per second. And it is asking us to find the rate that the radius is expanding. So it's asking us to find dr dt, where the little r there represents radius, so that's something we don't know. And then they tell us that the radius is 4 inches at that moment in time. Okay, well, so let's get started. So if we're looking at, we know the rates here in regards to area, well, we're dealing with a circle, and whenever we have a circle with a radius r, the area of a circle is pi r squared. So we're going to start with pi r squared. Alright, now notice here when they give us the dA dt, that's in regards or respect to time. So given that we are now working with this formula here, as for our rates, for our area, we're going to differentiate that with respect to time. So this is going to give me dA dt, and I'm going to differentiate this, so this gives me 2 pi r and dr dt. Okay, now we want to go back and plug in what we know, so let's go back to this part here. We know that dA dt is 16 pi. We also know that at that moment in time the radius is 4, and we are looking for dr dt, so this is what we want to find. But we can plug in 16 pi and 4 for the other ones. So let's do that. So dA dt is 16 pi is equal to 2 pi, and then my r at this moment in time, and then dr dt. So remember, we're trying to find dr dt. So let's simplify this. So we have 16 pi is equal to 8 pi dr dt. And then if I simplify some more, so divide by 8 pi, I get dr dt is equal to 2. So the rate at which the radius is expanding is 2 inches per second.